Okay, section 1.4 is called percent and percent change. Okay, and let's just jump right in. The first kind of problem we're going to do is about finding a percent of a number. Okay, so example number 1. What is 25% of 80? So what number makes up 25% of 80? Really quick, there's numerous ways to do this, but I'm just going to give you a shortcut. I'm going to cut right to the chase. And here's what you do as like a shortcut, even though there's other ways to do this. So here's what we're going to do. We're going to take the percent, 25%, and we're going to turn that into a decimal, like the decimal form of it. And to do that, you take the decimal point, which is right here, you know, like 25.0 technically. So the decimal point is right here, and we would move it where? And how many places? We're going to move it to the left 2 places. So from here it goes 1, 2, and so the decimal point ends up being right there. And once we change the percent to a decimal, we're going to multiply it by the 80. And that's going to get us immediately to the answer of what is 25% of 80. And so on my calculator, just to make sure, I do that and I get a final answer of 20. So it turns out that 25% of 80 would be 20. All right? So in other words, 20 out of 80 is like a 25% portion or score or whatever the case might be. Number 2, nothing real different, kind of the same thing. We're going to take 45% with the decimal right here, and we're going to move it 2 places to the left, and the decimal form is 0.45, and we're going to multiply that by 50, and that's how you find, as a shortcut anyway, 45% of 50. So on my calculator, I go ahead and do that, and it turns out that I get 22.5 is 45% of 50. So if you were at a store that was like going out of business and something cost $50, a pair of shoes or something cost $50, and you were getting 45% off, you'd be getting $22.50 off of the $50. But I'm actually getting a little ahead of myself with that, you know, percent change comparison or example. So anyway, 2 more examples. This is where, you know, you might want to pause the video and try these on your own or whatever. I mean, or just try them along with me. Think along, try to stay one step ahead of me, I guess, at least as you let the video roll. Number 3, nothing different. 92% as a decimal is 0.92. And then we're going to multiply that to 156, and that's going to give us 92% of 156. So on my calculator, I do 0.92 times 156, and I get 143.52 exactly. No rounding needed. It's exactly 143.52. So again, in other words, 143.52 out of 156 is a 92% portion. Number 4 is a little bit different, maybe a little tricksy, but guess what? It's still the same steps. The decimal point is technically right there. When we move it 2 places to the left, I get 1.28. So that's what 128% is as a decimal. And I'm going to multiply it by 350. And, hey, just follow the steps as always. And on my calculator, I get 448. Okay? Yeah, you can do more than 100%. Some quick examples, I guess, to kind of help you understand it if needed. If I said what was 100% of 350, you would say 350. Yeah, 100% of 350 is 350. If I said, like, what's 200% of 350, that's kind of like asking what's double 350, So 200% of 350 would be the double amount, 700, you know what I mean? And so 128% is going to be, more than 350 because it's more than 100%. Hope that made sense as we move on to the second case problem we're going to do in this section. This kind of problem is where I want to know, some number is what percent of some other number. And usually, almost all the time, it's going to be like a smaller number is what percent of a larger whole number. You know what I mean? Let's see if that is all of our examples we're going to do, where it's like number one is like that. This is the smaller part, and this is the whole, and we want to figure out, like, what percent this is out of that. Like, if you get a 40 out of 80 on a test or something, what percent is that? Now, you might be able to know that in your head. Like, as I said that, you might go, oh, I know exactly what, because that's actually a nice, easy example to begin with. But let's just kind of go right to what the, common steps are going to be. Like, what's the shortcut? And here it is. Whether it's really easy numbers or really, really weird numbers, you're going to do the part out of the whole and make it a fraction, which is basically division, to kind of cut to the chase. You're going to do 40 divided by 80. That's what you're going to do. The part divided by the whole. On my calculator, I get 0.5. And now what you're going to do is change this decimal to a percent by moving the decimal to the right 2 places, which means, there'll be a space there for a 0, 50%. So 0.5 converts to a percent of 50%. And like I said a minute ago, when I said 40 out of 80, like on a test, was what percent, it might have already snapped into your brain that, like, oh, that's 50 because that's half. Half is basically 50%, you know what I mean? But the division is what you're going to do even with, like, tough numbers. Or just do it all the time, basically. Same thing over here. 9 out of 180, you're going to do 9 divided by 180. My calculator says that that's basically 0.05. And when I move the decimal to the right 2 places to turn it into a percent, I get 5%. So, like, on a test, if you got a 9 out of 180, that'd be a 5%. That is a humongous F. You know what I mean? But anyway, that's how you do it. 2 more examples. 15 is what percent of 36? Again, you might want to, well, almost too late. Pause the video and try these on your own before starting the video again. But, you do 15 out of 36. You do that as straight up division on the calculator. Ooh, look, what am I going to do with this? Because I'm getting a repeating decimal. Okay, I could, I probably would be okay rounding this off. Hopefully you're following along on your own calculator and you actually know what the heck I'm talking about right now. So please pause the video and grab a calculator so you can look at what I'm looking on a calculator screen. But, okay, ready? 3, 2, 1, here I go. What was I even saying? Oh, you could probably be okay rounding this off and estimating, but I'm going to go ahead and say that what this is as a decimal is 0.41, and then it's basically 6 repeating, you know. That's an exact representation, but like I said, a few seconds ago, you might be okay rounding that off, but don't round it off too much. Like don't, the more you round, the less exact it is. So I don't know. Let's just do this for right now. And so when I move this decimal 2 places to the right, it ends up here. And so that percent is exactly 41.6 repeating percent. I guess I might as well write it down just for the heck of it. If you were to round this off, you could say that this is approximately 41.67% or 667%, right? I would go at least 2 decimal points. I usually go 3 decimal places when I round off. So I would, I guess I would think better it'd be better if I would say 41.667%. But this is right here. That's exact, and so I guess I like that even better. Example number 4. Hey, this is the weird thing I was talking about that you're rarely going to see, I guess, but 62 out of 25. Imagine that like on a test. Wow, getting a 62 out of 25 on a test, like that's even better than 100%, right? Like holy moly, that's way better than 100%. There was getting a 62 out of 25. So here we go on my calculator. Dividing that 62 divided by 25, that gets me exactly 2.48. And remember, that's a decimal. And when you move the decimal 2 places to the right, in order to change it to a percent, you get 248%. Final answer. Third type of problem, we're going to talk about percent change. This maybe the best example is, something being on sale. You're getting 20% off. You're getting 15% off. If you're real lucky, you're getting like 50% off. Maybe the store is going out of going out of business. But there could also be percent increases, like a tax. You know what I mean? Like you go to McDonald's and I don't know what the tax is. What is it, like 6% or something? I don't know. That's not a complete guess. If I'm wrong, I'm only a little bit wrong. But you go to McDonald's and the price is whatever the price is, but then they tack on like 6% or something. At least in 2018 or maybe 2017. I know it. I'm pretty sure it at least used to be just 6% exactly, but I don't know. Whatever. It's not important. What's important is that you can have like a percent increase. You know what I mean? But it's always a percent of the original. Let me say that again. It's always a percent of the original starting amount. So here we go. This is going to be like a 2-step thing. Ready? Or at least it could be. At least that's the way I'm going to do it. Okay? So an increase from $100 to $130 is what percent change? Well, here's going to be the first step. First, you figure out the actual change. You do a little subtraction. Let's actually write this out. You probably were able to do that in your head, but it was a $30 increase. Well, increase. $30 increase. So what percent is that? Well, to figure out the percent, we compare this to the original amount, the amount we started with. We started with 100, so it's the $100 we're going to compare 30 with. And so 30 out of 100 You might be able to do that in your head. I know I can, but doing on your calculator, that's 0.3 or 0.3, maybe a little better. And now you change that to a percent by moving the decimal place 2 places to the right, and it would end up here. Got to do a little filler. And so it would be a 30% increase, which that seems right. I mean, it is. Going from $100 to $130, that's a 30% increase, because 30 is 30% of 100. A decrease from 40 to 35 hours is what percent change? Again, two-step process. We do 40 minus 35. I don't like that 5. I don't know what I was writing at first there. 40 minus 35 is just simply 5. So it was a drop of 5 hours. Yeah. But what percent is that? Like, compared to what you started with, what percent? So we do 5 out of 40 is what percent? Well, we do the division on my calculator, and the decimal is 0.125. And when I move that decimal 2 places to the right to go there, looks like it was a 12.5% decrease. 12.5% decrease. Another example or two, just for repetition, I guess. Going from 8 employees to 20 employees. First, what the heck am I doing? Wow, I think my brain just did that subtraction without me even realizing it. That was crazy, man. Uh, 20 minus 8. First, you figure out what the actual increase was. So we increased 12 employees with the quick subtraction, and then you've compared to what you started with. Again, it's always what you started with. 12 out of 8. Wow! Like, here's the thing. We doubled. Okay. I don't want to confuse you. Thinking about what I said earlier in the video, but. So let's just do the division. 12 divided by 8 is 1.5 exactly. And this decimal needs changed to a percent by moving it. So it's going to end up there, a little bit of a 0 to fill. And that was a 150% increase. So we increased. See, I don't want to confuse you, but so be careful here as you listen to what I'm about to say. So increasing by 100% would be like increasing by 8, which would be like a double. Like you doubled it, like you doubled your employees. So think about that. If your increase was 100%, you had 8, and then you gained 8, because that's 100% of 8. And so you ended up with 16, doubling in a way. You know what I mean? But anyway, but increasing to 20 was increasing by 12, which ended up being a 150% increase. That's it, eh? Well, really quick. At a store, the example, the situation is probably going to be more like in a store. It's not like, the price tag says, sometimes, all the time or whatever, hey, it went from $90 down to $80, and then you need to figure out the percent drop. You know what I mean? Normally it's like, hey, this what cost $90? Shoes, I guess, maybe some sneakers. So these $90 sneakers are, I don't know, 10% off. And maybe you want to figure out, that 10% drop gets you to where, you know what I mean? So, but I think you can do that based on these problems we did, So here, for example, I guess I'll change up my numbers because of this example right here. So let's say the sneakers cost $80 and the little tag said it's 25% off. You would do this mathematics to figure out that, hey, that's $20 off because 25% of this price is $20. So I'm getting $20 off. And if you get $20 off of 80, the final price would be $60. And, hey, not bad, I guess. But anyway, that's section 1.4.